Second problem that I saw, some people were bringing this like this. Two problems with that. I can't do that. That's a pretty immediate problem. Squaring something like that, no, you can't. Squaring does not play well with subtracting. What do I have to do first before exponents? And think about why it makes sense. What am I squaring? Do I know what I'm squaring yet? No, I don't know what it is yet. So how can I square it if I don't know what it is yet? So that's why we always do in parentheses first, so I see what the hell that is, so they can do stuff to it. You can't distribute the square through. Because what property, what operation is squaring based on? Or any powers for that matter? Multiplication. Beautiful. So squaring works really well with multiplying. It does not work well with subtracting. Squaring does not play well with subtracting. In fact, what would I really have to do? I saw somebody do this. I didn't take any points off because they got it right. But it just so sucks to do this. What could you do there if you didn't think to do the inside first? Foil, right? Good God, don't foil unless you have to. The only reason we ever foil is when we cannot do the inside first. If that wasn't a 6, but it was an x. Can I do x minus 9? What's x minus 9? L. No, I don't know what the hell it is, right? So I have to have a way around it. That's why foiling was come up with. They said, let's find a way around it. Because I can't do the inside first. Here, dear God, just do the inside. Right? What's 6 minus 9? Negative 3. Cool. And the next level of thing I saw people putting an 18 there. If you look through this problem, what's the only number that's dividing anything else? What's the only number that I'm dividing by? What's it say?
9.
Yeah, I'm only dividing by 9. If you do this first, what are you dividing by now all of a sudden? 18. Your answer is going to be a lot smaller than it should be, right? It says definitely not. Because multiplication, division, how do you do it? As it comes. What are you definitely going to do last up here? Subtract. Yeah, I'm going to do that subtraction last. So I didn't see a lot of people putting like a 4 here, which was good. A couple people did it, but not a lot. I like that. Because that 3 is multiplying by something. I can't subtract it from 7 yet. It's 7 minus, I don't know. So here, this is all, well, the next level, of course, is we did the p, parentheses. Now we have to do exponents. Cool. So then here, what do you get there? And then I saw this. I gotta be careful. I don't want to sound like I'm yelling at you guys or like, I saw you doing this. No. These are understandable mistakes because we see this and we say, well, negative 3 squared is positive 9. But what did we just do on the order of, I don't know, water into wine or something? What operation is this?
Multiplication.
And now we've got, so some of you guys saw me say multiplication cannot become addition, right? The mistake somebody made there was they forgot to leave the parentheses there to designate the multiplying. Okay, cool. Do you see that? So you got to be real careful about if it's multiplication here, it better be 3 times something here still.
So you don't, just because you got rid of, you made the negative 3
squared is positive 9, but what operation is here?
It's still multiplication.
Yeah, so you could either leave the parentheses in there, which means multiply, right? That these parentheses really just tell you to multiply. Because if I put this, it looks like 39. Or you do this. Put a little dot in there, which means multiply. How are we doing? It's got to be multiplication still here. It can't suddenly become addition. And now, what do? We did the P, we did the E.
Multiplication.
We do the MD as it comes, right? So do this piece as it comes. Negative 3 times 9?
27.
Negative 27. 27 divided by 9? 3. 3 times 2? 6. So do you see how each time, this is there, this divided by that is there, that's still there, so now it's 6. 7 minus 6, 1. So that's a problem that's pretty much exactly like the one any of you guys had on 1C. So you basically follow the same steps. Just really hoping you guys see the mistakes that you can make. And I understand the mistakes. I understand why they're made. Because we're kind of pounding in our head to bring that in there somehow, but it can't go in over the minus. You don't want to FOIL. It would work. If you FOIL that thing, it would work. But good God, I'd much rather just do that, right? If I can figure out what this is, do it. Okay.
Did you divide the negative 27 by 3? Is that what you did? Oh, wait.
What's it say to do right there?
Oh.
27 divided by 9?
I see
It's
it.
3.
Okay.
So this is what I mean. I think I said this before already, but the people who are really good at math kind of either naturally or they had a good teacher kind of show them how to break problems into parts. So that's really what I'm doing when I'm doing this, where I kind of underline. I think before I had this under just under, but this here is there, this here is there, this here is there. So I'm just doing a part of the problem at a time. And that one part is stupid easy, right? 27 divided by 9. Please, Jeff, make all my problems that. The mistake people make is it's in the middle of this problem. But I don't care about that. That doesn't even exist to me right now. That is there. Now bring those in.
So when you don't deal with the multiplication until after you've done the division?
Multiplication and division, you do it as it comes.
As it comes.
Neither one of them beats the other one. They're on the same level. Addition, subtraction, same level. You do it as it comes. I saw a little too much of this. What's the mistake there?
Negative. Or wait.
Can anybody see a mistake?
They did addition first.
Yeah, they added first. And really, you could add first if you realized that this is negative 1. So negative 1 plus 1 is 0, not 2, or not even negative 2, right? So to do this correctly, 7 minus 1 is 6, plus 1 is 7. And you get 7 if you do negative 1 plus 1 is 0. There's a 7 left, you get 7 still. So you don't do A before S. You don't do M before D. You do it as it comes. Cool.
Yeah, that makes sense.
I like it. It's my favorite phrase. Okay. I'm hopeful. But for those of you who had trouble on that problem, you need to be more methodical for yourself. Some of you guys are possibly a little too methodical. That's better than not being methodical enough. That's a hell of a lot better. But you have to be very methodical about. See how every single thing else stayed exactly the same. The only thing that changed was the one thing I did. Did one thing, everything else is still there in exactly the same place. Do one thing, everything in the same place. Do one thing, everything in the same place. Yes, ma'am.
Did you question like on D? Because I just went blank on that.
I think the thing that got people on D, and again, I'll do one that's like that.
B or D?
Oh, okay. Did I have two? Yeah, two different letters. Let's do that. Okay, so something like that.
You can't see your writing.
Oh. Gotcha. Thank you. Let me do something, and can you guys spot the mistake I make? I made a mistake.
It's plus 6x.
Yeah. Because what am I distributing here?
Negative 3.
-3. If you look at it as if you're taking a 3 in, you really have to do this. Because you haven't taken that negative in yet. I'd really rather not do this. I'd rather take the -3 in and be done with it, right? So don't look at that like there's a 3 going in with a minus. No, it's a -3. Because how can you rewrite a minus sign plus a negative? You could do that also. It really is a -3. So that's step number 1. That's a lot of people kind of, either they forgot to change the sign or they forgot to bring the 3 in altogether. So here this should be a plus. Cool. Negative times negative plus. And now it's just get your like terms together, right? And thankfully, most of you guys were good with just getting like terms together on this problem. These obviously can go together.
Minus 6. Plus 11x.
Cool. And that's not 5mx, right? You can't put those together. Not like terms. Cool.
Okay, wait, I got lost again. What did you just do? The second part was 6m over 12?
Here?
Yeah.
So now these are like terms, right? 6 of these minus 12 of these is negative 6 of these.
Okay.
And then 6 of those plus 5 of those is 11 of those.
Okay.
So just putting like terms together now. So it's exactly the same on 1D.
So you're not dividing right there then because of the lines?
No, I'm just kind of grouping my like
Okay,
terms.
okay.
Yeah, yeah. Cool. Okay, any other questions from there? Yeah.
I'm still confused on 1C. I understand that problem, that example that you had. My question is, on this example right here, I have 2. After I did the exponents, and I got my, it was negative 2 in parentheses squared.
Okay.
I got 4.
Okay.
And it's 2 minus parentheses 4 divided by 4. Multiplication, division come as they go, right?
Okay.
So what am I multiplying the 4 by?
So you have
2 minus
4 divided by 4
parentheses 4.
plus 3. Oh. Well, in that case, what's in front of that 4? What's understood to be out there?
Is that the 1?
Exactly. So you don't need these parentheses because there's really just a 1 out here. You really didn't need to write those parentheses.
It's just 4.
Exactly. Cool. So when parentheses are between two things, they represent multiplication. When parentheses are around a single thing, they're unnecessary. Right? Now here, if I had this like this, I don't want to put two negatives together and make it look like one big long negative. And then I miss, oh crap, it's supposed to be a plus 4 now, right? So you sometimes put parentheses just to kind of keep operations apart. Does that make sense? So parentheses don't always mean multiply. It's just when two things are sitting right next to each other, one in parentheses and one right outside, that's multiply. But here, there's really just a 1 there, so you 2 just make it 4. The big mistake I saw here is people said it was negative 2 divided by 7. But again, you don't do division last. You actually do division before subtraction or addition, right? So you have to do this middle part first. And then put those together.
So on that part, you would just do 4 divided by 4, and then you'd get 2 minus 1 plus 3.
Exactly, and then put those together. Cool. So if you had that version, you got a little more help there. That's 25% chance. Any other questions from the quiz? Yes.
B.
Did you say E?
B. Guess I should just went one by one. So this would be something like,
5 over 6 minus 7 over 2.
oh yeah. Let's make it. There. So you can do this the same way with the specific problem you have. My suggestion here, and again, you guys can do this different ways, but my suggestion, if you have trouble with this, what number do they have in common? I think somebody,
3 and 5.
they have a 3 in common. Because 9 is 3 times 3, 15 is 3 times 5. So now you see what he needs that the other guy has. What's he need that the other guy has?
5.
A 5. And what does the other guy need?
3.
Yeah, he's only got 1 3. He needs one more 3. So now what's on the bottom of both?
45.
45. So this will be 20 over 45 minus 6 over 45. 14 over 45. Cool. And that won't reduce because
So then we're done.
that's it, because it won't reduce. I can't remember, I think some guys had a problem that reduced maybe. You just got to make sure at the very end of the fraction, you just check to make sure it reduces or not.
Well, because I got 4/30, so I don't know whether that one could be used.
Oh yeah, they're both even. So you know that what can go into both?
2.
2. And then just think of that one more step, yeah.
So there, are you talking about right there?
Here, no, this won't reduce. His problem had a 4/30.
Oh.
So I could go, or I think it was, yeah. Yeah,
You E, letter E.
sure. Actually, yeah, let's do the same numbers. If I had a problem like this, some of you guys tried to use cross multiplying. That would actually work here if you put the right thing on the top and the right thing on the bottom. So like I always say, the more you understand, the less you got to do. But if you don't truly understand why it works, you're going to do it wrong and get the whole problem wrong. It's not a good way to go. How do I divide fractions officially?
Do you flip it?
Yeah. Reciprocal. Which one?
The last one.
The second dude, yeah. So make that 4/9 times. And now my suggestion is not necessarily necessary, but my suggestion is to reduce now before you multiply. So you don't have to make these huge things. What can go into both?
3?
Here. Sorry. Yeah, 3 will go into both of these, right? And here, 2. What's up? Oh, I want you to get this. So here's 4/9 times 15/2, right? Now, let me just show you more work than you have to do. I got to say that so you understand. This, I don't need to see this. It's just kind of explaining why this works. 4 times 15, isn't that 4 times 15?
Yeah.
And isn't 9 times 2 9 times 2?
Yeah.
Can't you now reduce this?
5. You can just multiply across and then reduce it.
Yeah, you could do that. And again, it was just a suggestion in the first place. But very often, if you don't reduce first, you end up with these huge numbers that either takes you a while to reduce or somewhere on the way you make a mistake. You know, so if you had 363 divided by 1008, that will reduce. If you had a chance to make them smaller numbers before you got here, would you have taken that chance? I would say yes, but it's totally up to you. So right here, division and multiplication, they are opposites of each other, right? So can't I, 4 divided by 2 is 2? 15/9, I can reduce that. 2 times 5 is 10, over 1 times 3 is 3. 10/3, you know, either way you do it. If you multiply across, you'll get 60/18.
So wait,
Right? What's up? This is the way you guys said you wanted to do it, right?
Yep.
And then you just reduce that. In this example, that's not that hard to reduce, right?
Yeah,
Yeah.
but when it's a big number, it's hard.
Exactly.
so you can either just go across, multiply across, or you can cross multiply.
Careful now. You always have to multiply straight across if you're doing fractions. But what else is true about fractions? Whatever's on top can reduce with whatever's on the bottom.
This, I'm just gonna be safe and go across.
I like it. It's totally
Right?
up to you.
Yeah, that's that too.
But that's, like, if I do that, that's guaranteed I'll get the right answer, as long as I go across after I flip it.
All right.
Yeah, I would rather just go across.
There you go.
It's like when is each one
But you're not going to give us problems that hard.
Why not?
one day we'll have problems that hard.
I don't plan on doing that
Okay,
hard
now,
ever.
just to make my point, this is why, guys, very often we'll do simpler problems to show a concept that will become useful later. So for example, a lot of things we're doing in fractions now, I'm trying to teach you in a way that when we hit the fractions that have variables in them, we'll know how to look at them. So, just like the word problems, very often you hit a word problem, you're like, I know the answer is 5. So when I put it down, you didn't give me credit because you have to use algebra to solve it. It's a simple problem so that it's not the problem that's going to give you trouble, it's the algebra. If you're learning algebra, I'm not going to give you a crazy hard problem to then also do algebra to. That would be extra evil. But the idea of cross-reducing has got to be something you're comfortable with for when it becomes necessary or the only thing you can do when we have variables in something like this. You have to be used to this cross multiplication at that point. Do you guys kind of follow what I'm saying?
Yeah.
So a lot of times I do have a purpose as to why I show you a certain way to do things. And even then I say this is a strong suggestion. If you want to do it this way, go ahead. Here, I sort of went a little silly, but I hope you can see I would not multiply these things, good God. Because right there, those go away. And then 2 zeros go out, and 7 goes into 21. So the answer is 3. Instead of getting whatever the hell ugly thing that is, over whatever the hell ugly thing that is, and then trying to reduce from there, no. Yeah.
The only reason why doing it the way you say to do it is confusing is that I don't know where when I get that 3 goes into those and stuff like that, but I don't get where it goes.
Oh, I see. Watch this. You ready? So you're cool up to here?
Yes. Yeah.
Okay, so then what's 15? Isn't 15 5 times 3?
Yeah.
And 9 is 3 times 3? Okay, so the 3's here cancel. And 4, of course, if I wanted to, is 2 times 2. So there the 2's cancel. So the shortcut then is to not rewrite 15 as 5 times 3 and 9 as 3 times 3, but just to say, oh, the 3 that they both have cancels. Instead of writing it out, just say, oh, a 3 goes into that and a 3 goes into that. So that's the balance, right? You can't just take a 3 away from the bottom. You also got to take a 3 out of the top to make it balance. So that's the part that you don't write. So it doesn't take you forever to do these problems. You just say, oh, a 3 goes into both, a 2 goes into both, and then you don't end up with possibly big old ugly numbers. Yeah, cool. That's the kind of question I want to hear. So I really have to be careful with my patience with you if you sort of give up on a problem and don't come up with a question. Ask me a question like that. I love that. Say, the reason I don't like this is because I don't know where it goes. I can do something with that. I can show you where it goes. But you just got to give up on it. I'm like, don't give up on it. That's the worst thing. I hate that. Ask me what exactly it is you don't like about it.
Can you do another problem like that?
Like that
We
one?
can so I can try it.
All right, here, try this. You can do it, Jeff. Maybe. I could have made a division and then you would have flipped it. I think we're cool with flipping and making a reciprocal for dividing fractions.
I'm already lost.
Is it too far away? Yeah, I think so. Let's see. I want this class to be, I love teaching math because I love the perspective you bring. I look at math differently than a lot of you guys do. But I want you to realize you should feel free to ask anything. Say, this is why I don't like this problem. Why does that happen? Those kind of questions I love because it has to make sense. There has to be something that makes sense. I just have to find out how to say it so that it makes sense to you also. Because we all have a different way of looking at things. So here, what can we do?
You can multiply across, right?
You could.
That's the easy part.
Yeah. So now you say, and again, you always look up and down first. I mean, does anything reduce this way? No. Nothing goes up and down. Then you've got still multiplication and division here. So still legally, I can reduce these. So what goes into 8 and 20? 4. 8 divided by 4 is 2? 5. And then what goes into both of these? 3. 3 into 33 is 11. 3 into 27, 9. Sorry.
Wait, what did you divide the 33 by? Was 3? And they both went with 3. I see.
Yeah, exactly. 3 goes into there, 3 goes into there.
Got it.
Wait.
Cool.
Oh my god, I hate math.
What's up?
No, I don't know. Keep going.
Now, of course, based on what I just said, the phrase "I hate math" will not get you very far with me. But I understand your hatefulness towards math, but you gotta be more specific. 2 times 9, 11 times 5. Okay, cool. That's all I ask. I'm not asking you to suddenly love math. I would never do that. I'm asking you to be more specific with the problems you have in math. Yeah.
So doing it that way, would you ever get a problem that you need to reduce further?
If you miss something here, if you reduce everything here that you can, your answer never has to be reduced.
Okay.
That's the awesome thing about it. So here, I wouldn't even have to waste time thinking about this, because I know nothing here goes further.
Yeah, I was just wondering.
So I know I'm done. So there's a little
different
fringe benefit of this method. I know I'm done.
problem.
If I just got that answer though, I'd be like, oh crap, let me think. I'm fine, wasted time. Yeah. You good? Okay.
For example, if you multiply across 20 cents times 8, that's 216, right? I think.
216? Yeah.
Yeah, and then divided by across, 20 times 33 is 660.
Yep.
And then,
Now you can reduce.
okay, so say you reduce it by 2.
Okay.
Alright, so that would be 73, right? Or no?
By
Oh,
2
no, I'm
you
sorry.
said?
Hang on, I forgot how I got 73 though.
By 3, you did by 3.
By 3?
Yep.
Yeah, there you go, by 3.
So that'd be 72,
Or 330?
220.
Oh, 220?
Because you're dividing by 3.
Oh,
right?
okay, that's where I did it wrong.
Okay.
Alright,
Alright. So I'm not one to I don't want to say gloss over your fraction problems. At the same time, I got to manage my time also. So we got to be moving forward. But I do not want you to ever feel like you shouldn't ask a question. Always ask a question. So I think last time we did 2-6. We finished up 2-5. Any other questions from the word problem sections? Is that mine? No. Yeah. Mm. Okay. So this is page 116, number 12. This is a direct from English to math. So I made this point before, just really to hammer this home. It's exactly like translating from Spanish to English or from English to Russian. It's the same idea. We have symbols in mathematics that mean certain things, just like language has symbols that mean certain things. So here, if 4 is added to twice a number. I was like, that's not a sign you were getting.
The bug, yeah, and I got it. So good. That'd be crazy.
I saw it, I'm like, what sign is that? No. If 4 is added to twice a number, so how do you write just that piece by itself?
4 plus 2x.
4, I love it. 4 added to twice, meaning multiplication. A number, I don't know what the hell it is. You can use your favorite letter. You can use a Russian letter there, I don't care, whatever letters you know. Right? X is just a random thing. I can use A, use beta, Greek. Anyway, and this sum is multiplied by 2. So what's being multiplied by 2? The 4? Did it say 4 is multiplied by 2? It says this sum is multiplied by 2.
We'll put it in parentheses.
So this whole thing, the sum is multiplied by 2. The result is, okay, that's English. What's that in math? The result is equals. So real quick, just to see what we've done. If 4 is added to twice a number and this sum is, or twice the sum, how to say it? I forgot already. The sum is multiplied by 2. The result is, okay, the same as if the number is multiplied by 3.
Okay, so
The number's multiplied by 3, 3x, and 4 is added to that product. There it is. So there's the mathish that came from the English, right? Okay. And then I think it says, should say solve. Yeah, it says solve. And then you just, now this should be the easy step, right? Solving this problem. So I'm going to stop there. Is that good? Whoever asked that question?
Yeah.
Okay, cool. You have a question about this one?
Yeah, about the 3x, how do you?
It says the result is the same. You with me?
Yeah.
That's where the equals came from. As if the number is multiplied by 3. And what have we already established the number is? X. So I better not use some other symbol here because we're calling the number X.
Just that one number.
You wouldn't say Y, it didn't say some other number. It says the number, that number you already used. Good. Okay. Yes, good. Sorry.
I have a question on one of the problems in the lecture notes.
Okay.
On 2.6, it doesn't have a number before it, but it's the last one of the page.
From, you mean the lecture, my lecture notes, or from the book? Oh, good. Okay. See if I brought mine. No. What's it say?
Do you want to use mine? It says, one of the applications of ratios is unit pricing. We often look for the best buy, so if we convert the cost to a ratio per unit, we can easily see the best buy. For example, what is the best buy ketchup?
Okay. And then they give you some different things.
Yeah.
They tell you this many ounces for this much money, right?
Yeah.
So what do they tell you?
14 ounces for 93 cents. 32 ounces for $1.19. 44 ounces for $2.
Let's agree to do everything in dollars. Is that cool? That's 93 cents in dollars. Is that right? Because not a whole dollar. It's 0.93 of a dollar.
And 44 for $2.19.
Now, if you go shopping, very often what they already have is the unit price on the little labels. Which along with automatic change machines have taken away where most of us get everyday practice with math. It sucks. It's like, damn. Right? Well, it did kind of used to depress me when somebody couldn't give me the change back from like $4.70 from a $5 bill. Oh, what's change on? No, please. But now they don't even get practice with that. It sucks. So a lot of us don't know how to do this kind of thing. Being poor college students should give us motivation to be able to do this in case I go somewhere that doesn't do this for me automatically, right? You want to get the best buy. The funny thing is, these aren't always the best buy. In fact, there's like some cereal. I like me some Fruity Pebbles, just to admit that. If you don't, that's too bad. Just takes me back to my youth. And the funny thing is, the smaller size of Fruity Pebbles turn out to be better cost than the big one. And people don't even stop to think about it. They grab the big one. Oh, I'm going to save some money. No, you didn't. So in this case, how do I find out? What do I do?
Divide the money by the...
Good, you make a ratio. Money to ounces, so you can see how much it is per ounce. And then you can compare. Why can't I compare these right now? Because they're all based on different sizes, different amounts, right? If I set up 0.93 over 14, money to ounces, money to ounces, money to ounces. If I do that division, effectively I'm going to have over 1 ounce. Because if I divide 14 into both of those, I get 1 here and I get something there. It'd be per ounce then, right? So I'm going to end up with per ounce. This is money, dollars per ounce. What is 0.93 divided by 14?
Somebody do it for me. Oh, no, I messed up.
0.066.
0.066? Okay. It sounds about right. Per ounce. What is 119 divided by 32? So forth, right? That's what you do. What is 1.19 divided by 32?
0.037.
0.037? And what's 219 divided by 44?
0.49.
0.49. So what's the best buy? What's the cheapest one? The second one. Yeah, the one that's in the middle, not the biggest size. That's a little evil. Right? That's almost as evil as making the bottoms go up like that, so they put less stuff in. Have you noticed they're doing that now?
Yeah.
Ice cream, or mostly it's
Chips.
yeah, well, chips. That forever they've been evil. You open it, it's halfway gone. You're like, what just happened?
No.
It's like you're sacrificing chips and it's gone. The universe took its part.
Pinch them to make sure there's plenty in there.
Yeah, exactly. You guys see, so this is the best buy. Not the biggest size, but the middle size happens to be the best buy. Okay. So that's another example of setting up a ratio, price to amount. If you divide it, that's a unit price. Why do they call it unit price? Because the word unit very often means one. Cool. Yeah.
When do we need that notebook?
I am probably going to start referencing it in chapter 3, because when we get to graphing and stuff, that's where it's going to become easier for me to have examples already ready. So I'm trying to give people a chance until we get to chapter 3. I'm going to start referencing that $5, I think, or whatever it is, orange or pink, whatever it is, booklet. Yeah, it's in the bookstore. Yeah.
Actually, they just had a whole new ship. I guess you're not the only teacher that uses them.
Yeah, all of us do.
Yeah, they just had I went in on last Thursday and they just had a shipment come in.
Okay,
So they had
good.
to-
So if you went in looking for it, it wasn't there, it is now there. And that's why I'm not referencing it yet, because I remember somebody told me it was out.
Yeah.
So I asked the department chair and she must have, okay, cool. So there should be plenty in there, so go get it if you haven't gotten it yet. Yeah.
Oh, I'm sorry, I was stretching.
Okay. So now, one last thing out of section 2.6, and then we're going to get into 2.8, and that's all we got for today, actually. So that's kind of nice.
It was number 44, but it was on section 2.4, page 150.
Section 2.4?
Yeah, page 150, number 44.
Number, which one, sorry?
44.
44. Oh, yeah. All right. Page 119, section 2.4, 44. Find two consecutive odd integers such that blah. I don't care with a blah yet. They've given me enough information to do the first step in a word problem. Don't draw it. But how do you represent two consecutive odd integers? What's the first odd number? Because I don't know what the hell it is, right? So it's x. What's the second odd number have to be?
1.
X plus 1.
3.
X minus 1.
Give me an odd number.
3.
-1.
3. What's the next odd number?
5.
What's the next one?
7.
What do you keep adding? 2. So if this one is x, the next one's got to be x plus 2. That freaks people out because they're like, 2 is even. But the odds are separated by 2. If they weren't, they'd fall on an even number. Yeah, that's no good. It can't be even and odd. So 1, 3, 5, 7 is by 2 because 2, 4, 6, 8 is also by 2. Right? They can't fall on each other. So if the first odd is x, the next odd has got to be 2 more than that. Like you just told me, 3, 5, 7. 33, 35, whatever. 109, 111. It's got to be 2 more. So let me make a point right now. This is how to represent any 2 consecutive odd numbers, period, in the universe. Right? So if I want the 2 numbers 1007 and 1009, are those 2 consecutive odd numbers? Yes. I make x 1007, and then this is automatically 1009.
Odds, that's why you add 2. There's 2.
Because odds are separated by 2. So the first one's something, the next one's got to be 2 more than that.
Okay.
How are we doing?
Hang it in.
All right. Here's my point. What did I just say? This is any odd numbers, any consecutive odd numbers ever. But we want the 2 that specifically do what? So find 2 consecutive odd integers such that twice the greater is, all right, let's stop right there. And this is already where people kind of give up maybe. Which one's bigger? The second one. So it says twice the greater. So how do you write that? In math. Twice. All right, so there's twice the bigger one. Is equals 17 more than the lesser one.
17 plus x.
I like it. 17 plus x or x plus 17. So, do you understand? I'm really desperately trying to get you to understand. If I didn't set this up for myself, how the hell could I ever get this set up? Because it's referring me to this. If I don't have this, what the hell can I do? Twice the great. I don't know what the hell it is until I write it down. Now I know what it is. I can put it wherever I need it. That's why the first step, that's why I said if you don't draw a picture, the first step is identify in math what everything is. Because then it can use them where you need them. And now should be the easy part, right? Now's the part you go, hope that's right. Now let me just solve this equation, right? Okay, maybe. And let's see, what do we get?
2x plus 4. 17.
So subtract x. Subtract 4.
Why, what made you, how
So we're not.
how did you know to subtract the x instead of the 4? I would have subtracted the 4 from both sides.
Oh, if you subtract the 4 first, the next thing you're going to do is subtract x. I mean, so much of what we do doesn't matter what order you do it in. I got to get my x's on one side and my numbers on the other. So you wanted to get your numbers together first.
Yeah.
And then you're going to still have to minus x next, aren't you?
Yeah.
So it doesn't really matter if you subtract x or subtract 4 first? No.
I guess not.
It doesn't. Yeah. Because this happens a lot in math. I need something to happen, right? I need to turn left and go up. Well, couldn't I go up and turn left then? Most of the time. It's a bad example because sometimes there's a canyon in the way if I do that. But in math, there's no canyons. If I need something to happen, I can do it one first or the other one first. Yeah.
I just had a quick question on the 2.3
Oh,
math.
before we go away, am I done?
You have to plug it back in.
Yeah. So this is 13, and this is
15.
15. And thank God they are consecutive odd integers. If they weren't, I did something wrong. Yeah.
I did the equation, and after getting down to
Which one? I'm sorry.
64,
64.
on 2.3,
2-3.
page 104. Just
Yeah.
After I combined all the like terms, I got to 12t equals 12t plus 20. But I already know that if I subtract 12t, I get nothing.
No. Well, yeah.
Or
You get that on one side. What do you get on the other side?
20.
Okay, so you get 0 equals 20.
Which doesn't, so does it just mean no
When is
solution?
0 equal to 20?
Never.
So what would the answer to that equation be?
No solution.
Does anything work? No, no solution.
Okay. I don't like zeros in math as answers, so I wanted to.
No, that's not even 0 as an answer.
Well, it's not a solution.
A lot of people get confused when you get this as an answer, you put no solution, but that is saying x is 0. That is a solution. Leave poor 0 alone. He's a viable number. It's when you get 7 equals 2, or like you just did, 0 equals 20. Math is trying to tell you, hey, your equation is good when this is good.
Yeah.
So we go, shit, that's never good. My equation's never good. There's no answer.
Okay.
Cool. Okay. And that, you gotta love that about math. That's math being honest. That's math saying, dude, if you want to say that, I can say this. And you're like, shit, well, okay, I can't say that. I guess my equation has no answers then. Right? Math has got to have a way to tell me that there's no way that can happen. And I love the example I gave you guys. I'm filling in all this stuff and it says equals $1 million. I want to make $1 million. Math says, like, shit, I better take my million down a little bit.
So was that number 3 on page?
Which one?
The one she said.
Number 64.
164.
On 2-3, yeah. So that one should come out to be no solution.
Which number? Sorry.
Number 64.
Sorry.
64 on 2-3. So there's a little freebie. Don't just put no solution. Show me the word. What's the symbol for no solution?
0 with a slash.
Good. So be careful. Don't write 0 like that because you're telling me no solution. Write 0 like that. I've already picked up on a few. If you do this, like this, I know what you mean, but still, technically, you gotta get away from that, because that officially means no answer. It'll be alright. Okay. Oh, along with the email I'm going to send out with the practice test, I'm also going to email you guys with the workshop schedule. So they set a few workshops. They got at least one word problem workshop set, some fraction workshops. So I'll send out the schedule for that. And they should also have it posted outside the Math Study Center if you're interested in those. Those are free. And most of them are led by instructors. There's a few of them led by tutors. Most of them are led by instructors.
Yeah.
So let me know if you have trouble with your email. If you're not getting emails from me, let me know. Let's do the last section we have to do in chapter 2. And then we're done for the day.
You weren't going to go back to 2.6?
We
Or are we done with
Oh, yeah, there was one last thing in 2.6. Almost forgot. One last thing in 2.6. 2.6 is all about setting up those ratios, like the unit price one we just saw. There's one last kind of problem in 2.6 that has a little bit of a geometrical aspect to it. Well, a lot of one. And that's a problem like this here. We just try to make one up. Let's see. Oops.
Are you using a certain number, or are you just showing an example?
I'm just showing an example. Shit. Let's see. Now, I understand that there are quite a few of you who could just tell me what the answer is. Great. If you don't, that's okay. If you do, sit on that answer, set up the math, and see if it comes out to be the answer you know it should be. Don't just put the number down. So these are similar triangles. They tell you at the beginning these are similar. And they actually describe what this is in the book. They tell you that that means that they have to be, one is just a multiple of the other one. I just blown this triangle up. So if this side is 4 and that side is 4, and now it's 16 and 16, how many times bigger did I make it? 4 times bigger. So this is how you can kind of reason out what this last side should be. What should this last side be?
3 times.
What do we say? It's got to be how many times bigger? 4 times bigger. 4 times 3 is? So it should be 12. Well, let's set up the math and see if the math agrees. If the math doesn't agree, we can throw out math. Don't get too excited. You have a lot of options for this. Let me do the most popular one. You do one side to its partner, right? You do those one side over the other side. So small triangle to big triangle. 4 to 16. Small triangle to big triangle. So how should this be? And then you, for example, cross multiply, right? That's the shortcut for these problems. Once you set up a proportion, which is an equation with 2 ratios, then you can cross multiply, right? How we doing? You guys see that? 4 must be to 16 the same as 3 must be to x, because they're made from the same thing. Everything here has got to be the same times bigger, right? So what do you get here when you cross multiply? 4x. 48. Divide by 4. 12. Like we said, so you can't throw out math. Sorry. For those of you who are hoping. Do you guys get that piece? That's the last set of problems in that section. Is a bunch of similar shapes. In this case, similar triangles. That's all you got to do is set up ratios of sides. And you should be able to kind of tease out what the answer is going to be, so you can pick up if you make a mistake easily. If I got 7 there, I did something wrong.
Is there going to be any that's like a square and they have 2 sides? Or maybe not a square. Never mind. Squares are equal. Just kidding.
Squares would be nice. That's all right. Don't worry. Come on. But no, they could be like other
We'll just
shapes,
like
but we're
X
just
and
gonna
then
stick with
X
triangles,
equals
yeah,
2X.
yeah. Remind me, what kind of triangle is that? Cool. Isosceles triangle. Okay. So let's knock out this last section.
Are we skipping?
Yeah, 2.7, if you'll see on their homework sheet, is not in the curriculum from the beginning. So 2.7, there's nothing assigned. It's not in this curriculum, it's in your next math class curriculum, 103 or 110.
And that means it won't be on the test, right?
Won't be on the test. That would be really evil of me. I'm not that evil yet. Give me a few years.
I get to be an old professor.
So let me just see what you guys know already. Do me a favor. Do what you know about these next two problems. Graph. It's not really graphing yet. Right? Just have to use a real number line. Okay. Just want you to plot those graphs. Let me help you out. On a real number line. So we're not doing this yet, okay? Not x and y. We've only got a single variable. On a real number line, just graph those. I'm not going to do one now. No break, yeah, I'm sorry.
No,
Yeah.
no, don't be sorry. It's all good.
So make sure we're on the right track. The first thing you should be putting down on both of these, it's your number line. I'm not going to require you to be overly explicit as to what you show. This is 7, so maybe start at 6, 7, 8. I used to have somebody who did 0 up to 10 and negative 10 for everything. I'm like, you don't have to do that. Don't do that. Greater than 7, right? It's not less than, because it doesn't look like an L. That one looks like an L. That's less than. So that's greater than 7. Which way? The beautiful thing is, if your variable's on this side, the symbol shows you which way to shade. It's pointing in that direction. But what do you put on the 7?
Open circle.
All right. Open circle. And then shade up. Now, here's the change that Math 90 gets you ready for. Oops, yes.
Well, what did the circle mean? I'm sorry, I forgot.
Why did you not tell me to shade it in?
Because you got greater than equal to.
Exactly. You only shade where it's allowed to be that number. So it can be 8, right? 8's bigger than 7. It could be 7.5. It just can't be 7. So that circle, am I going to shade it in? No, because it's not part of the answer, right? So that's why the circles are the way they are. If it was shaded in, that would mean it'd be like this. It's allowed to equal negative 4, so it'd be shaded in. Here's the thing now that I've discussed what the circles mean. We're not going to use the circles. We got to get you ready for what's used most often in mathematics a little higher up. So Math 90 is kind of our transition. We go from circles. And what does that really mean? Open circle means, are you including that or excluding that? Excluding it. You don't want to include it, right? So instead of an open circle, we now use a parenthesis. So it's sort of like part of an open circle. Do you see that? So we use, instead of an open circle, we use a parenthesis.
What's the difference?
Just a different symbol. And I always ask you to please wait until I show you the whole picture. And you'll see how this relates to the next level up. Okay? So we use this, in this case it would be like this. Because you want it pointing Like it's containing that stuff. It's containing it. If I had one going down less than, it would be this way. You guys with me? And it's really simple to remember. Use a symbol that looks like part of an open circle. Parenthesis. So over here, how would you do this one before? What would you put on the -4?
Closed circle.
And now we would. In the past, we would put in a closed circle, right? Because we shade it in because it's allowed to equal -4. And of course, it's pointing me in that direction. Okay, cool. But now we're going to use, and again, remind me, does this mean include or exclude? Include. So, include. You use a symbol that looks like part of an I. Use a bracket. I'm trying
I could go either way.
to give you ways to remember it.
But
Right?
where do you put the bracket at though, like where the 4 is at?
Exactly. Instead of a circle, we're going to put a parenthesis if I don't include it and a bracket if I include it. And one other way to remember this is it's the symbol that's got the lines if there's a line. I'm trying to give you triggers to remember when to do which. So in this case, it should be open which way? It should be open this way. You guys see that? So that it contains, it kind of points in the direction your shading goes. Yeah.
So with the brackets or parentheses, does it matter if it's less than or equal to, like, because with the circles you would shade it in or leave it open? Does that part matter anymore with the brackets?
Sorry, is that which part?
Because if the sign shows that it's less than or equal to, you would shade it in.
Good.
Do we do anything like that with the brackets?
No.
Okay, so
Because the parenthesis means don't shade. The bracket means shade.
Can we do both? Like,
okay. So they're two different signs.
You could, and I'd be okay with that, because like I said, Math 90 is the transitional class. It's trying to get you away from the circles and more towards what's used in all of mathematics after this. Right? So here comes, let me give you a couple more examples. I'm going to do it without the circle at all. But there's nothing wrong with you putting like a circle and then putting on top of that a parenthesis. I understand that. That's cool. That's transitioning from one type to another. Let's try another one.
Yes.
If I have x less than -2. So try to graph that. So what goes on the -2? What goes on it now? Parenthesis, cool. Which way am I going to shade? That way. So am I going to do the parenthesis like this or like this? One or two?
First option.
The first one, exactly. So I'm going to go this way because my shading is that way. I like it. Cool. So that's the thought process you use. You say, I would put an open circle, so that means I use a parenthesis.
So you're figuring out that x is less than -2, whatever x is.
No.
So what you're doing here is you're showing me visually what numbers work here. Isn't -3 less than -2?
Yeah.
But is -1 less than -2?
No.
So see how that's not included? And this is more of a containment symbol. It says my answers are contained here on this side. Yeah.
So if x was greater than -2, the parenthesis would just go
Would have
the
gone
other
that way.
Okay.
Exactly. Cool. I like it. Doing good. Cool. So of course, the only other example I can give you is just do that. So basically, is everything possible? Oh yeah. Okay. Oh good, they do that.